In the fast-evolving landscape of artificial intelligence, I present my project entitled Nurturing Innovation, Bridging the Academia and the Public Sector Through a Research Center for Artificial Intelligence. This project is a response to the rapid emergence of accessible machine learning tools such as DALL-E, Midjourney, ChatGPT, Killbot, and deepfake generators. The central premise of my project is to enable and facilitate innovation in the field of AI through the establishment of a physical research center that promotes collaboration and experimentation among AI experts in allied fields. Its key feature, however, is my use of AI tools in the design process. The proposed site for the AI Research Center is situated in Quezon City, Metro Manila, the capital region of the Philippines. It is adjacent to key research institutions such as the State Department for Science and Technology, the National Institute for Physics, and the Institute of Mathematics, which can provide valuable support for the research center's activities. However, the site's unique characteristics also present challenges. It is largely fenced off from the surrounding urban fabric, which, while providing security, isolates it from the city. To address the issue of poor urban connection, the project proposes the creation of a public park at the front of the site adjacent to the avenue, ensuring engagement with passers-by. AI tools played a central role throughout my project's development. These tools are strategically applied in the programming, design translation, and schematic design phases to enhance the project's efficiency. To begin the programming phase, I conducted desk research to identify essential spaces required for the research center, including libraries, classrooms, and a black box theater. However, the project goes beyond the basics. Recognizing the need to accommodate allied fields like visual arts and social sciences, I consulted ChatGPT to determine additional spaces necessary for these disciplines. The resulting list of key spaces integrates my own research findings with ChatGPT's recommendations, aligning them with the project's design goals. The design translation phase involves the transformation of conceptual ideas into tangible architectural elements. I established the concept of the neuron as a guiding theme for the design, given its historical significance in AI development. To visualize what a neuron-inspired architecture might look like, I turned to DALL-E, an AI tool by OpenAI. Using the prompt neuron-inspired architecture and specifying various architectural styles such as brutalism and deconstructivism, I generated 44 images. These images were then analyzed to identify common themes that could be incorporated into the design translation. In the schematic design phase, the project used Spacemaker to generate massing studies. 32 massing studies were produced, and 4 were initially selected based on their consistency with site analysis and their suitability for applying the design translation concepts. Comprehensive analyses such as daylight, noise disturbance, sun exposure, and wind flow were conducted on each of the 4 massing studies. The study that performed best across these climate adaptability parameters were chosen as the foundation for further development. The selected massing study served as a starting point for design development. The concepts of connectivity and centrality were emphasized, leading to the inclusion of connective elements between the 5 primary masses. An essential addition was a footbridge connecting the research center to the College of Science complex, enhancing accessibility for students and faculty. At the very front of the site, like a buffer between the building and the avenue, is an art park for public installations related to AI. The courtyard was placed as the central facility around which the main building masses were organized. This served as an open space for assembly and recreation. Kinetic aluminum sunshading panels, controlled by computers to adjust automatically to the sun's direction, are incorporated into the facade, enhancing the building's functionality and sustainability. To reinforce the project's digital character and express the neuron concept, architectural projection mapping is proposed. This dynamic feature allows for the projection of caustic patterns on concrete surfaces resembling neurons. It also serves as a platform for announcements and promotions, further engaging the public. Efficient zoning and circulation are crucial aspects of the design as well. The design development maximizes the use of the lot while maintaining orientation towards the avenue. project addresses the lack of supportive spaces for AI innovation in the Philippines and proposes a way in which we can incorporate emerging AI tools in our design process. Human creativity perseveres still in our industry that is being permeated by the machine.